You've heard me say before in this part of the course about Kubernetes that it's rather unopinionated, which means it gives us a set of tools and commands, but it doesn't really prescribe one way to do things. And I guess the more ways you could do something, the more you might say it's unopinionated because you can just choose whichever path you'd like. Well, we've talked about in the previous section about three major ways to do Kubernetes or to manage your Kubernetes workloads, right? And the third one, the declarative, the fully declarative way, is the one that I want this whole section to be about, which means we're going to be mostly focusing on YAML and how that works in Kubernetes. And the reason I want this whole section to be about the declarative way is because it's more of the DevOps style. It's more conducive to the infrastructure as code, and the new term on the block, GitOps, which is all about storing your YAML and configurations in Git repositories and using Git commits to change your infrastructure. Now, I don't want to get too much into GitOps here, but really it's just about applying the automation style of DevOps to your configurations, and what better way to do that in Kubernetes by using YAML. And the nice thing is there's very few commands you got to learn here. Really, all the focus is going to be learning the different YAML formats. And here we're using the kubectl apply command with a -f to tell it, here's the file I want to give you, and that's the command. That's the command you use to create something. That's the command you use to update something or to edit a configuration or to change the image or whatever you want to do. That's the same command. In that way, it's very much like stack deploy in Swarm, where you're just constantly giving it the same command with updated YAML. For this section, we're going to skip that middle type of deployment, which has the kubectl create and the edit and the replace and those commands, because they're not really a good way to manage production infrastructure anymore. They don't have a good, solid DevOps structure to them. And this course is all about DevOps style containers. So that's what we want to strive to. So do realize, as a disclaimer in this slide, that surely you can use those commands if you want, but that's not really the primary way I think you should be using Kubernetes. And so just because this is the way I recommend it doesn't mean that there isn't a lot of other possibilities out there. So let me just throw you some quick examples of different ways you can use the apply command. And you've seen that we can just tell it a YAML file and it will apply something that's in there. Maybe it's a deployment, maybe it's just a pod, maybe it's a service or a job or a cron job or some other resource. But that -f will work on a whole directory. So you could have a bunch of different objects or resources sort of spread out in different files, maybe one file per resource. And you could put all those in a directory, and you could just point it to that directory, and it would bring in all of those. And of course, one YAML file can have multiple resources in it, and I'll show you how that looks in a minute. But another interesting option here is kubectl apply with a URL. So we give it that -f, but the file is technically a URL there, and the way it knows that is through the HTTP protocol. And in my case, I've created a domain that has a couple of examples. There is a pod.yaml file there, and so technically if you ran that command, it would work. It would deploy a single pod. But just be careful of these files because, it's one thing to pull something down over the internet and download it, but it's a whole other thing to one-line run a YAML file in Kubernetes. This is kind of the equivalent of curling something into shell and just allowing it to run on your system without even looking at the file, right? So you really don't want to do that. We don't want to be randomly running stuff, and that's kind of what Kubernetes does, right? It runs stuff. So you might want to curl that if you have curl locally, and if you're on Windows PowerShell, then you can use that command to open it up in your browser. In the next lecture, let's start looking at YAML formatting and how we're going to create these objects. I'll be honest, back when I first saw Kubernetes YAML, I was really intimidated. It seemed way more complex than Compose format. And that's for good reason. It adds tons of flexibility, tons more things you can do with it, but that comes at a price. And that is getting over the hump of learning the basics and how to make these files. When you first start looking at these files, there's so much to it that I wasn't even sure what was going on when I first saw these files. So totally understand if you are feeling a little bit confused about this as we go through it. Just try to rewatch these videos because I'm going to try to break this down in the way that I think is best for learning Kubernetes YAML. And first up is we could write this technically in JSON, but YAML tends to be easier for humans to manipulate and read, and JSON's better for computers. So what's happening in the background is the standard for us humans is to write the YAML, and then it's going to convert that into JSON. You technically could write the JSON, but the standard with Kubernetes for humans to write is YAML. And like I said before, you can mix or match these files. You can have many different resources in a single file, and then do the opposite of that, where you have a single file per resource. It doesn't really matter. It's up to you. The commands work the same way. And we're calling these manifests. So the full description of a resource is a manifest, and that manifest has requirements. And you'll see those requirements as 4 root keys inside the YAML file. Root meaning they're at the very beginning of the line. And that starts with API version, there's kind, there's metadata, and there's spec. So you have to see those in every file for these resources to work. And let's just look at some quick examples from the command line. So if you're in your Docker Mastery repo, you will see a K8s-YAML directory where I've put some of these examples in here. Now, if you don't do that directory, then you may need to do a git pull to get the latest updates to the repo. And if you've made some changes in the repo from taking this course, that's fine. You can either use a git stash to stash those changes away temporarily and then do the git pull, or you can just copy it down into a different directory, just clone it in a different location for this part of the course, because this Kubernetes stuff is newer than the original stuff, so some of you may be coming back at this later and don't have the latest updates. And the first example here is just a simple pod. This is probably the simplest YAML we can create. And like I said earlier in this course, you won't be making that many pods because that's just creating like a Docker run, and that's not really something you're going to want to do. It doesn't have rolling updates. It's not a deployment, right? But if you ever need to troubleshoot or you just need to run something simple locally, you could do this. And you'll notice that it has the same 4 requirements: the API version, the kind, the metadata, and the spec. We'll talk about what those are in the next lecture. But for now, I just want you to see how this kind is pod, the metadata has the name attribute. That key is the required key of all YAML objects. They all have to have that name, just like Docker run has to have a name. All Docker objects have to have a name. Same with Kubernetes. And the spec here is the meat, and we'll get to that in a moment. Let's take another look at a deployment. And here is a single deployment with 2 replicas of that same container. So it's probably twice the size, but for good reason, because if you think about it, you're creating that deployment resource, and then that is creating the replica set, and then that's creating the pods. So the spec area gets a little bit more complex because it's doing more things that we have to define. You'll notice also that our API version is slightly different because that's related to the kind, and the kind in this case is a deployment. It's kind essentially means resource, and the API version is the version of the API for that kind. And the rest here makes hopefully a little sense to you. It looks a little bit similar to compose files, but obviously the format's different. So I understand it can be confusing, especially if you're working back and forth between compose and Kubernetes. And in this example, I have combined the service and the deployment for that same type of deployment into a single file. So this is how you would have multiple manifests in a single file, is you use the 3 dashes to break those 2 apart. And that is sort of a YAML thing that will tell Kubernetes, hey, this object is unique, and then the next part is a new object. And you can have as many as you want in here until it gets so unruly that you just have to break it out. And you'll see with this first part, the API version is v1 of the service resource kind. The word kind here probably could just be resource, but they've called it kind. Metadata here, again, got to have a name, and the spec. And that's going to be totally different based on which resource you're creating. And then a similar deployment to what we had earlier, which this case, I have 3 replicas, and it's got a slightly different name, but other than that, it's the same Nginx. So just by looking at that, you're thinking, wow, I must need templates that I'm going to store so I know how to start, because this seems quite complex. And there is no single docs page that spells all this out for all the different dozens and dozens of resource types and how each one needs to be set up. That's unfortunately something that we got with Compose, where it was a nice single, although long, web page on the Docker docs for the entire Compose format. In this case, we don't get that with Kubernetes simply because there's too much complexity and it's not all in one place. So It's not even one app. You can actually add more resource types by adding more things called CRDs that we'll talk about later. We can get into that. But basically means you can extend Kubernetes with more resource types, more third-party stuff, which would even add more options to this YAML. And that's unique to Kubernetes. Swarm and Docker doesn't allow for that. Their format is set, where this one's quite extensible depending on what's installed in your cluster.